This is the TRIG version, or the TRIG section of the Secondary Math 2 SAGE review. I'm going to go through and I'm going to do the evens and hope that that gives you a resource to remind you how to do TRIG. We haven't done it for a long time, and then you can go back and you can try the odds. So we're going to start on problem 84. The question on 84, it's really important that you read what it's asking. 84 asks you to find the measure of each angle. Compare that with number 90. Where it says find the value of the trig function. This one, I just want us to find the sine value. I don't need to find the angle. I don't need to find the missing side. I might. But really my goal is only to find the trig function, not the missing angle, not the missing side. So there's two different types of questions there. Let's actually start with number 90 while we're here. There's one word that you will use to remember what the different ratios are, and it is SOHCAHTOA. Sine stands for opposite over hypotenuse, cosine stands for adjacent over hypotenuse, and tangent stands for opposite over adjacent. So jumping down to number 90, sine, we're looking for the opposite and the hypotenuse, the SO part of SOHCAHTOA. It's always based on some angle. In this case, it's the angle theta that's marked. If you were standing right here, what would each side be? Well, across from the 90, that's always the special side, that's the H. If you are right here, the side that's not by you would be the opposite side. So the one you would have to walk in order to touch would be opposite. And those are the two that you need, O and H. The problem is I don't know what H is. Conveniently though, you should have a formula memorized that deals with a right triangle, and that's the Pythagorean theorem. If I know two sides of a right triangle and I'm looking for the third, I can use the Pythagorean theorem to find the last. So you've got 9 plus 36 equals x squared. 45 equals x squared. Now I want to always leave these in radical form. So to find x, by radical form I mean I don't want any decimals. So x would equal the square root of 45. If I can break that down, I need to. 45 is 9 times 5, and then 9 is 3 and 3. So the square root of 45, groups go out, loners stay in, just like some people on Friday night. Then, if I want to rewrite that, the square root of 45 is 3 square root 5. 3 square root 5. All right, so SOHCAHTOA, sine opposite over hypotenuse. So sine is, our opposite is 6, hypotenuse is 3 radical 5. And then there's a rule that you can't have a square root in the denominator. So the only way to get that square root of the denominator is to rationalize. If I multiply the top and the bottom by the square root of 5, now the square root of 5 over the square root of 5, that's the same number as just 1. So I'm multiplying by 1, I'm changing the way the number looks, but I'm not changing its value. On top, you'll have 6 square root 5. On bottom, you'll have 3 times 5, because the square root of 5 times the square root of 5 is just 5. Now notice, on top I have a 6, on bottom I have a 3. I could have canceled this earlier, but I didn't. If I divide the top and the bottom by 3, I get 2 over 1. So to finish this off, it was a lot of work and it's kind of all over the place. I apologize, but the final answer would be 2 square root 5 over 5. And that's it. Number 92, if I want to find the cosine, this is the angle I'm looking at. Put yourself right there in the angle. Cosine is the so part. This is the hypotenuse, it's the special side. This is the adjacent, it's the one right next to you that's not the special side. And again, I need to use the Pythagorean theorem to find the adjacent side so that I can find the cosine ratio. So the side squared plus the other side squared. So leg squared plus leg squared equals the hypotenuse squared. 49 plus x squared equals 225. That's what 15 squared is. If I subtract the 49, I'll have x squared equals 176. I'm not entirely sure. So you can always start by taking the square root of 176. You get a decimal. That means I need to break it down. That side right here is the square root of 176. But 176, I know it's divisible by 2 because it's even. So I've got 88 times 2. I'm running out of room here, so let me just kind of carry it on right here. 88 can be broken up as 8 times 11. 8 is 4 and 2, and 4 is 2 and 2. So when I circle my groups this time, I've got a group of 2 here, I've got a group of 2 here, and then I have a loner 11. The square root of 176, that group of 2 and that group of 2 come out, they make a 4 square root 11. This right here, 4 square root 11. So at this point, all we have to do is finish this up. Cosine is adjacent over hypotenuse. Adjacent is 4 square root 11. Hypotenuse is 15. I check to make sure nothing reduces. I don't have to do anything weird. I can go ahead and simplify. Or I can go ahead and solve it. It's finished. Cosine theta is 4 square root 11 over 15. Alright, let's jump back up to number 84 now really quick. Find the measure of each angle indicated. So this one, I need to find theta. It doesn't matter if I use sine, cosine, tangent. I've got to use what the information gives me. I'm not looking for a specific one like I am on 90 through 93. My goal, find theta. So this is my angle. If you're standing right here, the h is the 10. The other one next to you is the adjacent. A and h uses cosine. So we'll say cosine of theta equals adjacent over hypotenuse. Now you need to know how to cancel a cosine. If I were trying to cancel an x squared, I would take the square root. If I were trying to cancel a divide, I would multiply. I'm going to do the inverse operation. Well, that means what's the inverse operation of a cosine? That's cosine inverse, or arc cosine. That's how you write it. It's the -1 thing, which we don't say because that's not the right terminology, but that's what it looks like. Cosine inverse and cosine will cancel. Theta will be by itself, and this is how you plug it into your calculator. You will say cosine inverse of 7 divided by 10, 45.6 degrees. All right, number 86, find the measure of each side indicated. So you still mark the angle. You still need to know where the OH and A is. So if you were right here, this is the special side across from the 90. The adjacent side is the one next to you. The opposite side is the one that you would have to get to if you walked through the triangle. In this case, I don't care about hypotenuse. I only care about the O and the A. Is that sine, cosine, or tangent? It's going to be tangent, TOA. Tangent of what? It's always tangent of your angle. Tangent 38 equals opposite 5 over adjacent x. So how do you solve for that? X is on the bottom. What are you going to do? You have to get x out of the bottom so that you can finish the problem. Multiply by x, multiply by x. Those cancel. I like to rewrite this. It is possible right now to change this tangent 38 into a number, but if you do that, it's not my favorite way to do it, but if you do that, I'm not going to just put 0.7 or 0.8 because that's too much rounding. I want to round all the way out here, 0.7813 or 0.78128, as far as we can out, because the more you round, the more unreliable your number will be. So when people build bridges, when they build roller coasters, we don't want to have a whole lot of rounding error. We want to be as exact as possible. So this is how I'll do it. Tangent is multiplied by the x. So to cancel the multiply, that's what we're canceling, is the multiply. I'm going to divide both sides. And I'll get x equals 5 divided by the tangent of 38. There's no inverse because I'm not solving for an angle. That side right there, 6.4. That's all you have to do. Number 88. On this one I have to solve the triangle. Solving the triangle means you find every missing side and every missing angle. The first angle is the easiest to find because I know all of the angles added together equal 180. One of them is 90, one of them is 74. So the measure of angle B is 16. It's my first one. Now I need to find side BC, that one down here, and side AB. The first step is we have to use trig, so let's just put an X somewhere. I don't care which one it is, let's just start somewhere. So if that's the angle or the side I'm trying to find, let's use 74, because that's what was given. There's several ways to do this. That would be the opposite side. This would be the adjacent. OA, sine, cosine, tangent. We're going to do tangent. Tangent of your angle always. So the tangent of 74 equals opposite over adjacent. Now we have to look and see what's on bottom. We have to get rid of whatever's on bottom first. Let's divide 15, so I'm going to multiply by 15. So x is by itself now in one step. 15 times the tangent of 74 equals 52.3. So what was that? BC 52.3. All right, one last one. We need to find the hypotenuse. You could use trig again if you wanted to. I like trig, but you don't have to. If you didn't want to use trig again, what do you do when you know two sides of a right triangle and you're looking for your third? You use the Pythagorean theorem. So 15 squared is 225. 52.3 squared is 2,735.29. If I add those together, I get 2960.29. So we're right here. And then if I want to solve for x, I have to take the square root, and that's going to be my answer. So we will square root our answer, and we get 54.4. Fantastic. Moving on, number 94. Find the measure of each indicated angle to the nearest degree. Now that's just like the ones we did on the other page. It's just like number 84. So if you need a reference, look at number 84. And I'm going to skip that one and move on. Number 96. If the tangent of x equals 4/3, find the sine and the cosine. So let's set up our triangle. We need to mark a variable. It's always the tangent of an angle, so you need to put the x in here somewhere. It doesn't matter where the x is, you just put it somewhere. I'm going to put it down there, that's where I always put it. Tangent is TOA, so opposite over adjacent would be 4/3, which means the opposite side is 4. Opposite on top both times, the adjacent side on bottom both times. And in order to find the sine, cosine, and tangent, we're going to need the hypotenuse. Again, if you know two sides, you're looking for the third. Let's just set up the Pythagorean theorem. Now 3, 4, 5 is a Pythagorean triple. So if you remember, 3, 4, 5 is a match that always forms a right triangle. You don't actually have to set up the Pythagorean theorem. This was supposed to be x, by the way, because you know 3, 4, 5 and work. Also, any multiple of 3, 4, 5. So 6, 8, 10, 30, 40, 50. They all work. 9 squared plus 16, or sorry, 9 plus 16 equals x squared. 25 equals x squared, so x equals 5. Which means if I want to find the sine of x, sine is opposite over hypotenuse, 4/5. If I want to find the cosine, Adjacent over hypotenuse, 3 over 5. And that's it. All right, number 97. These last ones are story problems. As soon as you set up the triangle, you're going to solve them exactly the same as you did before. So I think I'll do 97 and 99 and call it good. You can finish the rest. Number 97 says a kite with a string 150 feet long makes an angle of 45 degrees with the ground. So you've got the ground, you got this kite string. This little kid right here is holding it. And the angle it makes with the ground, it tells us, is 45 degrees. That angle right here is always going to be the angle that you're referring to. Doesn't matter if it says angle of elevation or angle of depression, we're always going to put it right here. Always, always, always. Always. So the kite string is 150 feet long. 45 to the grade. Assume the string is straight. How long or how high is the kite? Meaning how far off the ground is it? So you have to decide where the x goes. If I want to know how high is the kite, that's the vertical distance from the ground. And now you do it the exact same way we've been doing our other problems. Mark the angle. Label the side. The x is the opposite. The 150 is the hypotenuse. OH uses sine. Sine of your angle. Always sine of your angle equals opposite over hypotenuse. Now how do you solve that? You have to get rid of the divide 150, multiply by 150. So x equals whatever 150 times the sine of 45 is. 106.1 feet. Okay, it's 106 feet off the ground. It's pretty high. All right, one more. Number 9, a tree 10 meters high. Casts a 17.3 meter shadow. Find the angle of elevation of the sun. So again, the angle makes a right triangle. The angle is always on that bottom corner. It will never be up here. Because technically, this right here, angle of elevation, this right here, angle of depression, those are the two words you'll see. But because of alternate interior angles, those are the same value. So I'm always going to put it on the bottom. Never on top, always on bottom. Because right here it's outside the triangle, and then you get confused and then you generally get it wrong. Always on the bottom. Set this up. My angle, opposite, this one is the adjacent. We don't know the 90 this time. OA, it's going to be tangent. Tangent of what? Tangent of the angle equals opposite over adjacent. Again, how is the x combined with the tangent? It's merged into one. It's the tangent of x. This is a function. How do you get rid of the tangent? It's the inverse tangent. So I'm going to take the inverse of both sides. Tangent inverse of 10 divide 17.3 is 30. 30 point, yeah, just 30. X equals 30. And that is all. So let me know if you need help setting up 98, 100, 101. It is expected that by Monday you have all of these TRIG questions finished. I'm sorry I couldn't be there today. Hopefully you saw this. Hopefully it helped. It wasn't super long. And you've got half of those problems finished. So if you watched this video, come and tell me what your favorite color is, and you will get extra credit. Also, I want to see that these problems are done, so bring your packet with you. So this packet and favorite color. All right, everyone, peace out.